1.5 algebraic properties of limits and piecewise functions. So just to start out right here, this is pretty simple. X plus x, 2x. Okay, right here, the limit as x approaches c of f of x plus f of x. So this is 2 limit of as x approaches c of f of x. Very simple. Example 1. So it's just showing, the limit as x approaches -1 is 2, 1, 4, and 1, 6 of fx, fx, and gx. Yeah, see, the table above gives selected limits of the functions f and g. What is the limit of, as x approaches 1, of f of negative x plus g of x divided by 2? So we know f of x, as x approaches 1, f of x equals 4. But when it's f of negative x, you can change it to be as x approaches -1. So f of x is equals to 2, and then plus g of x over 2. So as x approaches 1, g of x is 6. So we could do plus 6 over 2. This simplifies to 3. So 2 plus 3 equals 5. So we could say that the limit as x approaches 1 of f of negative x plus g of x over 2 equals 5. So we know f of x, as x approaches 1, f of x equals 4. But when it's f of negative x, you can change it to be as x approaches -1. So f of x is equals to 2, and then plus g of x over 2. So as x approaches 1, g of x is 6. So we could do plus 6 over 2. This simplifies to 3. So 2 plus 3 equals 5. So we could say that the limit as x approaches 1 of f of negative x plus g of x over 2 equals 5. Example 3. The table above gives selected values and limits of the functions of f, g, and h. What is the limit as x approaches 5 of h of x multiplied by f of x plus 2g of x minus h5? So we just plug in the values. So we make this h of x is 3 multiplied by, oh, I'm sorry, it's not 3. It's 5 multiplied by 6 plus -2 minus 3. And this is going to come out to equal 17. So the limit of x as x approaches 5 of h of x multiplied by f of x plus 2g of x minus h5 equals 17. Example 4, piecewise functions. Very simple. To help us out, we can draw a number line, 5 right in the middle. So this is the limit of -5 right in the middle. The limit as x approaches -5 from the left, so this way. So x is less than 5. We plug it in here. 11 minus -5 is square root of 16, which equals 4. -5 from the right, so we use this equation since x is greater than 5. Plug -5 into this equation, so this is -2 over -5 squared, which is 25, 5 minus negative 25, or 5 minus 25 is negative 20. So negative 2 over negative 20, which is 1/10. And the limit as x approaches negative 5, since these don't match, the limit does not exist. Same over here, number line. In the middle, or since it's working with negative 1 and e, we'll put negative 1 here and e right here. This is just a visualizer. The limit as g of x approaches negative 1. So we could use this equation. Negative 1 squared is 1, 10 minus 1. 9, square root of 9 is 3. And then we can also check it in this equation. So we put in negative 1. So 26 plus 5 is 31. Oh, I'm sorry, my mistake. We don't use this equation, we just use this one. So square root of 9 is 3. The limit of gx as x approaches e from the right, so approaches e from the right, so you get a natural log of e cubed. This is 3. The limit of gx as x approaches e, you use either of these two, but for time's sake, I already done it. Answers does not exist.